So Snowflake. So any idea about Snowflake? Okay, if you are new, if anybody knows, you can speak out. Okay, so fine now. See, Snowflake is a cloud-based data warehouse. Okay, cloud-based data warehouse. So what is cloud-based? Why we are talking about cloud-based? So in general, we are having data warehouse concept. Okay, data warehouse concepts. So now, any one of you know what is warehouse? In
Yeah, it's where we store the data.
yeah, yes, where we data warehouse means where we store our data. So here warehouse in generic, where we store things. Okay, in a generic terms, warehouses means where we store things. So if we are dealing with the data, okay, then that warehouse where we are storing the data, where we are storing the information, data is nothing but a piece of information, right? So that piece of information where we are storing is called as data warehouse. Okay, so a place where we store data. Okay, fine. So now we are storing our data here. Why we need to store the data in a data warehouse? So why we need to store that? For our further references. Okay, for our further references, like for example, if you take your bank statements, okay, if you take your bank statements, we are all using our Google Pay, Phone Pay, or mobile banking, or we are having internet banking also. So why we are using that for transactions, right? So in our class we are having 7 members here in the class. Now all the 7 members all are using daily, on daily basis, we are using our daily transactions, we are doing daily transactions, either it is a credit or debit. Okay, or we receive the amount or we will transfer the amount, right? So those transactions should be stored. Okay, those transactions should be stored. So on daily basis, if I do 5 transactions per day, if you do 5 transactions per day, like that we are 7 members, 7 into 5, 35 transactions will be done on daily basis with different bank services. Okay, so every bank service or every transaction that we do with the different bank services, they should store the data. For example, if I lost my amount from my bank, okay, from my account, I lost some money. So I forgot, I transferred to someone else, or I made any purchase, or any transformation, any transaction has done, but I have forgotten it. So how I will recall it? So I need to search my bank statement. Either I need to open my Google Pay, Phone Pay, either I have done through that, or if I do any transfer from mobile banking, I need to open my mini statement, or if it is 3 months, 4 months back also, we can easily retrieve the statement and we can check, right? So how we are checking that bank statements? Why how we can check that? Because we have stored that, not we, the banks are, they are providing us some service and they are storing our data in some databases or in some data warehouses, isn't it? So how, if we are if we are downloading the statement, how we are receiving that statement? We are receiving that statement in the form of table, right? In the form of table we are receiving the statement. So if this statement need to come in the form of table, then where it should be stored? It should be stored in a database. So database is a place where the data is stored in the form of tables, right? So we need to have one database to store this data. So database means on regular basis, on daily basis, we will be doing transactions. It will store that. But there will be some limitation for this. Okay, there will be some limitation for this. Like limitation means some amount of data should be stored in databases. So some GB or some TB of data, like for example, 5 TB of data need to be stored here. Okay, the limitation with 5 TB. Okay, fine. Now, on daily basis, if the transaction happens throughout the world, or you take throughout the Hyderabad itself, there how many members are there? Like we are having, it's almost 3 crores of population in Hyderabad. So in that 3 crores of population, at least if we take we have if we take 10 lakh records, okay, on daily basis, if 10 lakh transactions happen, so how much data is generating? It's a vast data, right? So now if I need to store the data 5 TB of data in this database, if it cross 5 TB, then what is the solution for this? If it cross, there is no matter of increasing. That limitation is only 5 TB, but our data is increasing. So how I need to store rest of the data? For that, we are going with a data warehouse. Okay, for that, next data warehouse concept will come. So now we will be storing our data, whatever the data coming. For example, if in this database I will store 1 year of data, what happens for the last, if I am storing for 24-25, what about 23-24, 22-23? The data should be stored somewhere, right? So that place is called data warehouse. Okay, there we will store our historical data, a place where we store our historical data. So database is a OLTP process. That means online transactional process. So data warehouse is a OLAP concept. OLAP, which is online analytical process. So analytical process, in the name itself we have analytical. So analysis. So why we are storing the data means for analysis process. Like for example, take e-commerce website like Amazon. Go for Amazon. So they need to take some business decisions. Okay, they need to take some business decisions to how they need to improve their business. So we are having all over all we are having Amazon. Or for example, take to in our Hyderabad. In Hyderabad, you take 5 locations. Okay, take 5 locations. So for these 5 locations, they need to analyze how the sales are happening, which product is has high sales and which product have less sales, and how we need to improve our sales in that locality. So how they will analyze? So they need to generate report for every 6 months. Okay, and then they need to analyze their sales. So how they will get the report? So like somewhere it should be stored, right? So they are getting the data from this data warehouse. So and they need to generate the report and they need to analyze. So for that we have to have the historical data. So here we are storing data warehouse means we are storing historical data. Even we can store current data also. So that means historical data plus current data we are storing in data warehouse. So fine. You came to know what is data warehouse, what is database. So now why Snowflake we are using as a data warehouse? Why not others? Okay. See, as I told you, Snowflake is a cloud-based data warehouse. Okay. So now this cloud-based data warehouse means what? So you know data warehouse. We know data warehouse concept. Now what is cloud-based?
It's a virtual database.
Mm. Oh yes, it's a virtual database. Okay, that's one correct. Any others? Okay, see cloud-based, why we are calling this as a cloud-based data warehouse means, see, we are integrating when we are logging to the Snowflake, when we are signing up to the Snowflake account itself, we are integrating with the cloud. Okay, on top of cloud, we are going to create our Snowflake. We are not going to create Snowflake and then we are not going to integrate with any other cloud service. Okay, on top of cloud service only we are going to integrate, we are going to create our Snowflake account. Okay, so it is easily aligned with it is easily aligned with all the three cloud services. We have three cloud services, right? Those are Amazon Web Service, like AWS and Azure, and third is GCP, Google Cloud Platform. Okay, see, now we are aligning with all these three. So, as per the requirement of the company, we will be integrating our Snowflake with these three. But these three has their own data warehouses. Okay, Amazon has Redshift as their data warehouse, and Azure has Synapses as its own data warehouse. GCP has its own BigQuery. But why we are going with this Snowflake? So they had the cloud services has their own data warehouses, but even though if we have those, we are going with Snowflake. Now all the organizations are migrating. Okay, all the organizations are migrating their data from on-prem to cloud, right? So now why Snowflake is coming in the first place? Apart from all this, why Snowflake is coming into first place? Because it has unique features. It has unique features. So here in Snowflake, in Snowflake, see, it's a cloud based, as I told, it's a cloud based data warehouse. So it is very easy for us to store, to manage, and to integrate and to analyze the data. It is, for us, it will be very easy. We will write simple select statements. Okay, simple queries we will be writing, and we will be fetching the data. And if we find any bottlenecks, we have a query profile to see where the bottleneck, where we have a struggle for the query, why it is taking long time, the execution time, we need to refer the execution time. It is also very easy. That means we have user friendly UI. Okay, we have user friendly user interface. The interface is very user friendly. So here it is a SaaS as so SaaS means it's a software as a service model. It's a software as a service model. So why it is called software as a service model means, see, other data warehouses like traditional data warehouses, if we go with traditional data warehouse, so here what happens, there will be some limit. There will be some limit for storage. So for here, take 1 TB of limitation we have. For example, I am storing this 1 TB, the storage is full. Now what I need to do? I need to, again, I need to add some storage for this. I need to increase 1 TB to 2 TB. That means I need to add some physical storage disk here. So I need to purchase that physical storage disk. Yes, it costs around 5 lakhs. Okay, I need to purchase that disk which costs around 5 lakhs, and I need to integrate it in my data warehouse or data warehouse systems. So now this is 5 lakhs and plus additional 5 lakhs I need to invest. Or for example, this I have purchased previously, that means it is for 3 lakhs, and now I need to purchase one more TB for 5 lakhs, and the so total cost is of 8 lakhs now. Okay, so total cost is 8 lakhs. So now for few more days, for few more years, or it lasts for 2 to 3 years or 4 years. Okay, and after that again I need to, the space was full, and again I need to increase my space. Okay, I need to increase my space. Then I need to buy extra storage. Okay, so okay, this is one concept. And another, if I am having 2 TB here, I am having 2 TB of data storage space. Okay, but here I used only 1 TB storage space. Rest 1 TB is waste. 1 TB is waste. It was, we didn't use that. So now if you purchased 2 TB and you used only 1 TB, which is a 1 TB is waste. Now if 2 TB is cost around 6 lakhs, so now 6 lakhs is waste of money, right? Why? Because you used only 1 TB. So 1 TB will cost around 3 lakhs. If you say 3 lakhs is waste of money, right? That means the money was blocked here. But that was not the situation in Snowflake. Okay. And so for increasing the space, Okay, if for increasing the space, the storage space, if you need to purchase the disk and you need to integrate it in the data warehouse. So you need to do it manually. We need to do it manually. But in Snowflake, we don't want to do that manually. It is it is auto scalable. So it will automatically increase the storage space. Okay, so that is scalability. So why we are saying this as a SaaS means, so we don't want to manage anything on our, we don't want to manage anything manually. Okay, we don't want to manage manually. Everything will be managed by itself. Okay, everything will be managed by itself. Everything means what? Network, storage, infrastructure, everything, OS, everything, whatever we are using, whatever the things we are using in a Snowflake, okay, that are managed by itself. So there is no manual intervention here. Okay, there is no manual intervention here. So that's why we are calling it as a SaaS. Okay, understood. Why we are calling Snowflake as a SaaS, software as a service. Okay, so here everything will be managed by Snowflake. Fine. So this is also one of the case. If we are having two TB storage and we are using only one TB, okay, so and 1 TB is waste. So we are investing 6 lakhs of our amount and we are wasting 3 lakhs here. So here, this is one of the disadvantage of traditional warehouse. Okay, so that we can overcome in a Snowflake. That we can overcome in a Snowflake. So here what happens? So how much space, how much storage we are using? Okay, how much storage we are using, that for that only we will be paying. So that is one of the feature of Snowflake. Feature of Snowflake is pay as we use. Pay as we use or as you use. Okay. So this is one of the feature. In traditional data warehouse, there will be every manual intervention should happen. So the disk space will be remains empty. We need to pay for that. But here not like that. Here if we have 1 TB, we are using 500 GB, then we will be paying for only 500 GB. Okay. So why we are using this Snowflake? Now you understand what is Snowflake, right? So now why we are using Snowflake? Why we are using Snowflake? So why means, see, as I told you, it is a SaaS service. It is fully managed. It is fully managed. Means no server maintenance. No server maintenance, no network issues, no storage issues. Okay, no computation issues. Nothing. We don't want to face anything. So everything will be managed by Snowflake itself. So another is, see, it automatically scales. Okay, if it will automatically scales, like for if it is now, for example, today we are getting millions of 10 millions of data. Okay, so now the storage is storage will welcome that 10 million records of data. Tomorrow I got only 5 millions of 5 million records of data. Okay, fine. Tomorrow or day after tomorrow I am getting 40 million records of data. So it will adjust itself for the data, how much we are getting. It will adjust as per the data. Okay, that means scales automatically. So there is no limitation. Okay, there is no limitation for data storage or for computation. Or see, we when queries are running, query is running, for example, there is 1,000 lines of query running with 5 million records. Okay, this query is running with 5 million records. Now what happens if the load increases? Sometimes the query will take time, right? Sometimes the execution time will increase more than 15 minutes, or it may go raise to. Hello, am I audible?
Yeah, you're audible.
Yeah, sorry. Due to some network issue, the connection was disconnected. Okay, so see, we are here, right? Scales automatically. So that means whenever the query is running, with high more execution time is more, at that time it will adjust the compute resources. Okay, like if we are using, we are using virtual warehouse. We are having a virtual warehouse concept here. So that virtual warehouse, for suppose you are using Access, so it will automatically increase it. It will scales up. Okay, it will automatically scales up to yes or medium, whatever the size should be appropriate for that execution time. It will scales automatically. Once the query executed, okay, once the query executed, so next query is not taking much time, then automatically it scales down without impacting the query. Okay, without impacting the query, it will increase or decrease the computation resources, or it will increase or decrease the storage space. So that is that it will be done automatically in the Snowflake. And the next thing is it's a multi-cloud support. Okay, it's a multi-cloud support. Okay, multi-cloud support in the sense either we can go with AWS, either we can go with Azure or GCP. It will support all the three clouds. Okay, and then it supports structured and semi-structured data. So structured data, it means it will be in the form of tables, like it will be in the form of rows and columns. Okay, semi-structured data means JSON, Avro, files, different files. We will be here. We will be dealing with the different files. So it supports semi-structured data and structured data. So and the other thing is, as I told, pay what we use for that only we pay. So there's also one of the feature, pay as we use. So apart from this, we will be having a data share feature. Okay, data share feature where we can share our data. Okay, where we can share our data securely to other users. Okay, this is one of the feature we are having, data share. We can share securely, share the data. Large volumes of data also we can share. Okay, we can share large volumes of data also. So these are the main features of Snowflake, which take us to use Snowflake more in the first place. Okay, these are the main features of this Snowflake. So till here, do you have any doubts?
No, it's good.
Okay, thank you. So what we are doing with the data in Snowflake? Okay, what we are doing is data in the Snowflake. Yeah, what we are doing is we are going to process the data. We are going to store the data. Okay, we are going to store the data. We are going to process the data, and we are going to analyze the data. Okay, so as the data will be stored in the storage layer and the data will be processed here and the data analysis will also be done here. So see, as a Snowflake data engineer or as a Snowflake developer, we are responsible for giving a quality of data. Quality of data. Because why I am saying quality of data means, see, we are in the middle. We'll be having upstream teams, we'll be having downstream teams. Okay, so what upstream teams, what is downstream teams? Any idea?
Upstream seems like a development, the downstream teams like development or testing, upstream teams like management and the sales team.
No, not exactly. See, upstream teams means source teams, like source, from where we are getting data. Okay, source teams where we are getting data from. Okay, and in the middle we will be there Snowflake developers or engineers. And downstream teams means for whom we need to give the quality of data. That means we'll be having Power BI team. Okay, Power BI, Tableau, or data visualization teams, DV teams. So these are the upstream and downstream teams for us. Okay, we will be in the middle, and we will be getting data from source teams, and we will be giving the data to the downstream teams. So here, as a Snowflake developers or as a data engineers, we are responsible for giving quality of data. So when we ensure that the data was the data was cleaned, and data, there was no nulls there, and there was nothing, the data was formed in a structured way, then for downstream teams, it will be very easy to analyze, to create dashboards on top of this data, and to produce that to the business clients or stakeholders, or who is the owner of our business. Okay, so as a Snowflake developer or a data engineer, we are responsible for producing quality of data. So we are dealing with data. So what type of data we are dealing with, how we will be dealing with, and how we are segregating the data, everything comes as a comes under this Snowflake development part. Okay. So Snowflake goes with ETL process, ETL or ELT process. Okay. So the main do you have any idea about ETL and ELT processes? So no. So ETL process means extract, transform, and load. And ELT means extract, load, and and transform. Excuse me. Okay. See, mainly we'll be using ETL process here. Okay, mainly we'll be going with the ETL process. See, ELT is used for huge volumes of data, but if we are having huge volumes also in Snowflake, ETL, we can go with ETL process only. Okay, so what is this ETL process? What is extract? What is transform? And what is load? Okay. Load. So see, as I told you, most of the Snowflake developers or most of the Snowflake data engineers will be working with the data migration projects. Migration projects. That means migration in the sense, in general terms, what is migration?
Moving from one place to other.
Yes, moving from one place to other, right? So in the same way, here what we are moving? We are moving data. Data, we are moving from one place to another place. So from where we are moving to where we are, from where we are getting the data and where we are moving that. So that means, so we are getting data from source, we are moving source to targets. We will be moving the data from source to targets. Okay, source in the sense, they may be on-premises data warehouse or database Okay, target in the sense, it will be Snowflake data warehouse. Okay, so this is called extract load process. Okay, so from source we will be extracting data. From source we will be extracting data. That means we will be getting data. Okay, and then we will be transforming the data. And then we will be loading the data to target tables. Okay, so now source, transform, load. This is ETL process. And what we will do in this ETL process? See, if you think this is sorry. So if you take this is source and this is target. So here will be the transform. So if we think this is source, either it may be either it may be SQL Server or Oracle or SAP. So from these data sources are flat files. Okay, so from these sources, we are getting the data. So once we are getting data, what we will do? We need to extract that. So here extraction happens. So now what we have done here, extraction, here extract happens. We have extracted the data. See, once we extracted the data, we will not directly load that into the targets. So if we think this is target, okay, directly we won't extract the data into targets. Why? Any idea why we won't directly load that into the targets?
We need to apply logic as per the database.
See, because see the data which we are getting will be raw data here, raw data. Okay, that will be in a CSV file or files. That will be in the form of files, CSV files or JSON files or Avro, whatever that is. That whatever the data they are generating in the form of files, that will be a raw data. What is raw data? Raw data means it will not. It will be in a CSV file format. Means see, for example, CSV file means so that will be in the form of Excel. So let me show you what is CSV file. Okay, so see, this is a JSON file format. See, by seeing this file, so suppose assume the file is like this. See, by seeing this, can you understand what file is this or what type of data it is?
It is like an array inside array of objects and containing
Yes, it will be in the
multiple
form of
objects.
loop, nested loop, like right? So this is
Yeah.
one type, and this is one data. This is one column. Okay, like that. So, but now what we need to do this, we cannot see if we give this to directly to the client, will they understand this is the data there we are generating?
No.
No, right? So for that purpose, what we need to do, we need to segregate this data in the form of tables, like means in the form of rows and columns. Then only they can understand, right? So CSV file means it is a comma separated file. So in general, CSV file, how we can create, see, for example, I have ID, I have name, I have location. So this is comma separated file. This is one, this is Z, this is Bangalore. So the file will come like this. This is one type of file. Okay, this is CSV file format, comma separated value. So here what happens, we will be having null values. Okay, or we will be having blank spaces. So now, see, this is my column over ID, name, location is my headers. So I have one Z Bangalore. Sometimes, there will be blank values. Okay, there will be space. Okay, here some C I'll give. Here in location column, sometimes they will be like this, 8, like this, they will be. So now this, if I give this data to the client, will they understand what is this? No, right? So they cannot understand these type of files. So what we need to do, we need to apply our logic. Okay, we need to apply our business logic here. We need to transform. This is a transform area. Okay, here what we do, we need to apply our business logic. Apply business logic. Like data cleaning, null handlings. Okay, so there may be unspecified characters. We need to remove unspecified characters, okay, from the data. And then once all this happened, okay, then finally we will load our data into target tables. Okay, once this all done, the data is cleaned, then we will load that into our target tables. So this target tables, once the data is loaded into here in the form of tables, here the data will be in the form of tables. Here it will be in the form of tables. So these tables we will give to our downstream teams. We'll be having our downstream teams here like Power BI, DV or Business BI, okay, Power BI, BIT, DV or stakeholders. If we are dealing with stakeholders directly, then we need to talk with them. We need to provide this data to them. Okay, so this is called this total process is called ETL process. This whole process is called ETL process. ETL process. So that means we need to extract data from different sources. Here we may get raw data. Okay, different file formats we will be getting. Then we need to extract them to the transform layer. So it will be called as a staging layer. Okay, and then we need, once we need apply our transformations, we apply our logic, business logic here. Once the data, you assure that the data was cleaned, and then you will need to load the data into a target systems. Okay, here our target staging layer and target systems will be Snowflake. Okay, only the source systems will differ. So this will be same. This will be under Snowflake. Okay, here this will be under Snowflake. This we will do under Snowflake. Okay, so in the class, if we conclude, so why we use Snowflake? Snowflake we use for handling large volumes of data. Okay, so finally, Snowflake is for handling large volumes of data. Here what we can store the data, we can process the data, and we can analyze the data in the Snowflake. Okay, so this is a Snowflake UI. Let me open and show you. Excuse me. So this is the Snowflake UI. So here you will be creating your worksheets, and you will be working with this worksheets, working on this worksheet. So you need to create one database, create database, some, okay. So then you need to create one schema. So under this database and under this, okay, sorry, that's not. Okay, now under this database, I have created one schema. So your database will be displayed on the left side. So here I created one database. So under that I have one schema I have created. Now, as of now, there is no tables here. So now I need to create one table here. So these are simple SQL queries we will be writing. Create table. Some table, any table name. Convention will be as per our requirement, like our project requirement. So I am creating one table here. So now I created this table. So if you refresh here, so your table will be displayed under this tables category. So this is the table. So see, if you see here, the details of the table, you will be see number of rows. Now I just created the table, but there are no, I didn't insert any data into that. So size is also 0. See, owner, who is the owner, who created it, when it was created. And you can see the definition in the sense how you created the table, what command you used. Okay, so that you can see here in this user interface itself. So now I have created my table. Table was here. So how we will be inserting here data? Insert into input values. So what are the columns I have taken? ID and name, right? So 1. So now I have inserted one record. See, one record inserted. So see here, see, it will show you how much time it took, 640 milliseconds. It will show you query duration. So if you want to see the query details, so it will display you here. It will give one query ID. See, for every query we write, okay, for every query we write, it will generate one unique ID, okay, distinct ID. Why? Why? Because see, in Snowflake, we have different features called time travel. Okay, time travel, where we can retrieve the data if it is accidentally deleted by any one of our colleague, or any modifications done. But see, first client asked you to modify some data. Okay, so they asked you to enter Snowflake here. Okay, now you entered this Snowflake. But after few days, they asked you, instead of Snowflake, just update it to what? Update it to another name. Okay, they asked you to update it to another name. Update table, table, set name is equal to table name. So set name is equal to some, they asked you to create session further. Instead of Snowflake, they asked you to replace it with session. So you are replacing it where ID is equal to 1. Okay, so now if you see this data, select star from input. See, previously I have inserted Snowflake, now I have session here. So if you see here, see, this will be the query ID for this. So if you see here, this will be query ID for this. Okay, and if you want the query ID for this update statement, so this is my update statement, right? So the query ID is this one. See, observe, this is different and this is different. Okay, so the last FO92, here it is E0B2. So it will, it will generate a distinct query ID for every query we ran. Okay, so if you have any bottlenecks, if you found any error, so you can go to query history. Okay, you can go to query history. So you are having query profile here. You can see the query profile, how it executed, see how it, where it scanned the table, how what we did. Everything will be, you can see where the bottleneck is. Okay, if you are running 10-20 lines, so then you can see there will be one DAG here. It will create one DAG here. So you can see where the bottleneck is, why it is taking so much time. Okay, everything, the query detail. If you go and see this, what is the status of the query, how much duration it took. Okay, so what is the query ID, what is the start time, what is the end time, and warehouse size. So what warehouse we are doing or using. Okay, everything will be displayed on this UI. So you can monitor everything, you can track everything, the billing also. So if you go for admin part, the billing part, the security, users and roles, what users and roles we are using. Okay, see who are the users here, what all we have, or what are uh, the names of the rows we have here, or who is the owner of these things. So when it was modified, when it was created, everything will be seen here. So you don't want to no, you don't want to worry about anything. You can, in the interface itself, you can fetch everything here. So if you go to data here, so you see here we have databases. So what all the databases we are created, or we are using. So if you want to add data, so from the UI, you can load the data into tables. Okay, so either you can create a table and then you can load from your local machine, or without creating also you can load the data. So from stage, see it has given you all the clouds. The GCP was there, Microsoft was there, AWS was there. So everything was here. So you don't want to, that means you don't want to stay away. You don't want to get permissions. You don't want to get load the data. You don't. There wasn't much process. There is no much process. Very simple process it will be. Okay, so these are all everything we will be covering in our sessions. So this is all about Snowflake. So if you have any doubts, you can ask me.